Down to our final problem. So I note this is a temperature problem, so I go back on the previous page and check to see, what's that formula again? Oh yeah, Taurus said I was going to have to memorize it. Boo! So now I have, let Y represent the temperature of an object in a room whose temperature is kept at a constant 60 degrees. So this is the surrounding environment. That's my K1. And the object cools from 100 to 90 in 10 minutes. That'll be important to us later. How much longer will it take for it to decrease to 80? So going back to this whole temperature piece in here, so what I know is at time 0, the temp was 100. And at time 10, my temp was 90. So using my initial condition and the fact that I actually already know K1, now my formula is going to look like this when I plug in, oops, except I want to plug in 100. So 100 equals, I've got the 60 for K1, and my time is 0. So I'm going to have 100 equals 60 plus, remember all of this is going to be 1, so 60 plus C, which makes C 40. And then once I plug that in, so technically I have now a new form of my equation, which is T equals 60 plus 40 e to the kt. And then I can use this second piece of info and I can plug that in. So now I have 90 equals 60 plus 40 e to the 10k. And doing a little magic, I'll end up with 30 over 40. Convince yourself of that magic. E to the 10k. And I'm going to need a superhero to get that exponent down. So I'm going to natural log both sides. In this case, I have to rescue it by getting a log. And then, of course, the natural log of E will be 1. And if I want to get K by itself, I'll divide all of this stuff by 10. And I'm sure my hamsters will give me some ridiculous number like negative 0.02. Oops, I'll erase this and squeeze it back over. Come on. So K equals, I get negative 0.02877, which would make sense because it is cooling. Of course, if I want to leave it exact, then K is the natural log of 3/4, because that 30 over 40 reduces over 10. So I can plug that back in. Probably better because I have hamsters that can accommodate that. So now I know that my final formula is 60 plus 40 e to that crazy exponent, because that was my K value, times T. And then when it wants to know how long it'll take for the temperature to get down to 80, so now I would finish at a temperature of 80. And then I want you to pause the video and see if you can actually solve for T. And so I solve and I get T equals 24.09 minutes, but keep in mind that was using the initial value at time equals 0. So 24 minutes from the beginning, so that was from that 100 degree mark all the way down to time equals 0. And 10 minutes have already passed, so I could say, since 10 minutes have passed, that I'm going to need another 14.09 minutes.